Imagine opening a soda can. Psh, bubbles explode upward. Foam rises dramatically, and you suddenly wonder what invisible force created that fizzy eruption. Before we begin, subscribe to the Food Lab for simple food science explained clearly, practically, and in a way anyone can understand easily. Carbonated drinks fizz because carbon dioxide gas called CO2 is dissolved inside the liquid under very high pressure. When the bottle or can stays sealed, pressure forces the gas molecules to remain mixed evenly throughout the drink. The moment you open it, pressure suddenly drops and the dissolved gas begins escaping rapidly and visible bubbles. This follows Henry's law, which simply means gases dissolve better in liquids when pressure is higher. A clear explanation appears in the book on food and cooking by Harland McGee. McGee explains how carbon dioxide stays trapped under pressure and escapes quickly once the container is opened. He connects real kitchen examples with science, making complex gas behavior simple and practical for everyday understanding. Bubbles began forming at tiny rough spots called nucleation sites, meaning small starting points where gas collects first. A high authority explanation from Encyclopedia Britannica confirms how pressure and gas solubility create fizz in carbonated drinks. When bubbles rise and burst at the surface, they release aroma molecules, tiny small particles that quickly travel into your nose. That sharp, tiny feeling on your tongue is not just bubbles popping physically against it. Carbon dioxide reacts with water and forms carbonic acid, which is a weak acid, meaning it creates mild soreness. This mild acidity gently stimulates sensory receptors in your mouth responsible for detecting spice, temperature, and irritation. These receptors connect to the trigeminal nerve, the same nerve that reacts when you eat spicy food. Because of this stimulation, your brain interprets carbonation as refreshing, lively, and slightly intense in a pleasant way. Carbonation also pushes aroma upward, increasing smell intensity, and smell strongly influence how flavor feels inside your brain. That is why flat soda tastes dull, even though most ingredients remain nearly unchanged. This article explains how carbon dioxide stimulates pain receptors gently, proving fizz affects real biological systems. So fizz is not just bubbles, it is pressure physics, mild chemistry, and brain science working together in one simple drink. Next time you hear that loud hiss, remember you are testing science in action. So don't forget to subscribe my channel The Food Lab and see you in the next video. Bye bye.